Okay, kiddos, now we have made it to our last lesson of the semester. So we're going to be doing 8.4 today, mid-segments and proportionality theorems. Okay, so our essential question is, how are the mid-segments of a triangle related to the sides of that triangle? And what proportionality relationships exist in a triangle intersected by a line parallel to one of the sides? Wow, that sounds really tricky. But we're going to take it step by step, just like we normally do. So, we're going to talk about mid-segments and proportionality today. We've already talked about proportionality, right? We talked about that when we're talking about dilations, right? And similar things, right? Which means same size, same shape, but a different size, right? So what is a mid segment? Okay, you might think mid, right, meaning middle. So let's talk about it. Okay, so on a triangle mid segment. Okay, let's go through these definitions first, and then we'll look at a diagram for it. So the mid segment of a triangle connects the midpoints. Okay, we talked about what a midpoint is of two sides of a triangle. Okay, so that's what the mid segment is. That segment is always parallel to the third side. And that third side is half as long as the segment. Okay, so that's what a triangle mid segment is. Okay, so let's take a look. This is a picture right over here. So the mid segment connects the midpoints of two sides of a triangle. Okay, so we see this triangle right over here. Okay, and so let's look at this side right over here. So this tells us that this length and this length are equal, right? So if you have the same thing on one side as the other, then that's called the middle, right? So that's the midpoint, right? Check this out over here. Okay, this one and this one are equal, right? So if this is equal and this is equal, that means this is the middle, right? So the mid segment connects the midpoints together. So the mid segment would be this right here, DE. So the mid segment we would call DE. Okay, those midpoints we would say that's going to be point D, right? And E. Those are the midpoints. Okay, so that segment, this new segment, is parallel to the third side. So this is one side, right? That was the second. That's the third. So this is parallel with that. And we remember parallel means they never touch, right? Because they have the same slope. Remember that from Algebra 1 and from what we practice. And so that's how we'll do that, right? So that segment is parallel to the third side. So that's what those two mean, right? So the third side is half as long. Oh, whoa, let's mark over here. So which two sides are parallel, right? Remember that's parallel. So DE, that segment DE is parallel with AC. Okay, so now let's look at those relationships. We said the third side is half as long as the segment, that mid segment. Okay, so this one is half as the size of AC. So DE, if we said DE, would be AC. If it's half as much, that means it's AC divided by 2, right? DE would be this divided by 2. Conversely, AC, right, would be 2 of DE, right? So 2 times DE would give me AC. Okay, so if I start with the mid segment and I want to find this part, I just multiply it times 2. Okay, or if I start with this and I want to find that, then I do the opposite of multiplying, I divide. Okay, so that's what we want to think of. So the mid segment. Okay, so this mid segment is going to be equal to the base divided by 2. Okay, so that's going to be called the base, right? And then this is the mid segment. Okay, so the base divided by 2 gives us the mid segment. Or if we start with the base is going to be equal to 2 of the mid segments. Okay, so that's the relationship. This is half of this. Okay, so keeping that in mind, let's get right into some practice. All right, so it says we have 3 different style problems over here. So I'm going to help us out by doing this first. That's our first style. Okay. So in this first style, it says triangle KLM is formed by connecting the midpoints of triangle HIJ. So the midpoints of HIJ, right? So HIJ is there. The midpoints would be right there, and right there, right? So it says KLM is formed by connecting those three, right? So KLM, okay? The lengths of the side of HIJ are shown. Okay, so this right here shows the length of that side, right? That's 6, and that's 4. What is the length of KL? Okay, so this is what we're trying to find, KL. Well, if this is the midpoint, right, and this is the midpoint, here's what we know. Right? We know that this and this are parallel, right? So we can say that those are parallel, right? Well, if those are parallel, then what's the relationship? If this is 6, we said this has to be half of that, right? So the midpoint is the base divided by 2, right? So that means x is going to be 6 divided by 2, which is 3. Okay, so as long as we have that relationship understanding, then that's all we have to do. Okay, so they tell us that that's the midpoint. I know that's parallel, so if that's the base of 6, then I know that has to be half. Okay, so that's the first style. Okay, so now the second style. So that's, let's do this. Okay, so that's the first style when we're trying to find the mid. Okay, second style right over here. Okay, it says triangle TUV is formed by connecting those midpoints. All right, so TUV, right, is formed by connecting those midpoints. It says the measures of the interior angles of triangle QRS are shown. Find the measure of QTV. Okay, so that's looking for the measure of QTV. This was looking for the length of KL. Okay, so find the measure of QTV. So let's trace it out. QTV. Okay, so they want us to find, let's put this in a different color. They want us to find this, right? The measure of QTV, right? Well, what do we know? Okay, if that's the midpoint, right, and these are parallel, right, that means this angle is the same as this one because those are congruent. Okay, so if I know that, then I know my answer is 74 degrees. Okay, so once I know this, then I know that has to be that same amount. Okay, because this is parallel, right? That's parallel to that because those are midpoints. All right, so that's our second style. Now let's go to our third style. Okay, so on this third style, it says WXY. So WXY is formed by connecting the midpoints. Okay, the lengths of the triangle are shown. So we know that these are the midpoints. Okay, and now this one's a little different. This one gave us the measurements of the big one, right, on the outside. This one gives us the measurements of the small one. So we're going to go the other way. Okay, so this says find the perimeter of TUV. So TUV. Okay, so we know the perimeter means add all the sides. Okay, so we need to know how much these sides are. Well, if those are the midpoints, right, check this out. How much is this one? This one is twice as much as this, right? So if this is 3, that means this has to be 6, right? And then check this out. This one is half of this, right? So if this is 2, this has to be 4, right? And once again, this last one right here, this one and this one, right? If this is 3, this is, you're right, that's 6. So now our perimeter is going to be the first side plus the second side plus that third side, right? So the perimeter is going to be 6 plus 4. So 6 plus 6 is 12 plus 4 is 16 all day. All right, so those are our 3 styles. So the first style, if we're given the base and we're trying to find the midpoint, we just divide by 2. On this one, if we know that these are midpoints and we know these are parallel, so these angles have to be the same. Okay, and then the third one, we're doing the perimeter, but we start with the inside, so we know that the outsides have to be double what that is. And so we did that, and then we added those 3 together. So go ahead and do these practices before you move on to our next page. All right, so now let's step it up a little bit. So triangle proportionality. What that says is a line parallel to the side of a triangle divides the 2 sides proportionally. Okay, so what does that mean? Okay, so let's look over here. QS is parallel with TU, right? QS and TU, that's what this says. So if QS is parallel with TU, then this part relative to this, so if that's true, then the proportion of, say for instance this, right? This cuts this into 2 parts, right? So I'm going to say that this is the big part, right? And that's the small part. Okay, then it cuts this side into a big part, right? And a small part too. Let's do this. Let me highlight it differently. So that's the small part, that's the small part, right? And then we have a big part and a big part. Okay, so if these are parallel, what that tells us is this small part, so QT, over this small part, QT over TR is proportional to SU over UR. Okay, so if these are parallel, it divides those into proportional parts. So this to this is the same ratio as this to this. Okay? Conversely, we can go backwards. So if we knew that QT over TR is proportional with SU over UR, if we know that, then that tells us that QS has to be parallel with TU. Okay, so that's our converse. So we're working everything backwards, just like we learned the whole semester. Okay, so if these 2 are parallel, I know these have to be proportional to those, and then if I know those are proportional, I know those have to be parallel. All right, so let's keep that in mind. Going with our 3 parallel lines theorem. So in the similarly, 3 segments. If 3 segments are parallel, so this, this, and this, if all 3 of those parallel, those are also proportional. Okay, so we're going to think the same way as we just did right over here. So keeping that in mind, let's look over here. It says, given lines L, M, and N are all parallel. Okay, so it's telling us that this one, right, is parallel with this one. Okay, that's parallel with that one. Okay, so they're giving us all that information. So, find the value of x. Okay, well, if you can imagine, right, this is like a little triangle right here, right? So we have this triangle that's made, right? So that triangle that's made tells us that these are going to be proportional, right? So we can just set it up just like that. So let's go ahead and set up our proportion equals a proportion. So since this is on the left side, let me do that. X over 11 is proportional with 6 over 8. Okay, so now if we're just trying to solve for x, we know once we set up the proportion, we're just going to cross multiply like we practiced, right? So that times that and that times that. So 8 times x gives us 8x. 6 times 11 gives us 66. And then we know what to do. Our last step is always to divide. So we're going to divide by 8, divide by 8. X is equal to 8.25. Okay, but now let's look at this. We need to refine our answer. It says round to the nearest tenth. Okay, so remember we know the tenth means 1 digit after the decimal, right? So that means we look to that 2. So that means our answer is going to be x equals 8.25. We look at we need a one digit, right? But we ask our 5, what do we do with that 2? The 5 tells us to raise it, right, to 8.3. Okay. Oh, and actually it's not going to be equal, right? It's going to be approximately. So that's why we use that. Okay, so approximately 8.3. Okay? So keep it in that mind. Let's go to that next one. Just do the same thing on this next one. Okay, I know you can do this. Let's set it up. Okay, so it says L, M, and N are all parallel, right? So we know this line, and this line are parallel. So if we're trying to find X, we know we can set up those proportions, right? Those are going to be proportional to that. So 8 over 24 and X over 26. Now, let's just do our cross multiplication. X times 24 gives us 24x equals 8 times 26 gives us 208. Okay, now we just divide both sides by 24. Okay, X is going to be approximately 8.66666, right? And it keeps on going, and we're going to put this bar there. Tells us it keeps on going. But they want to the nearest tenth, right? So that means we just want one digit, right? So we look to the 6 to tell us what to do, right? So the 6 tells us to raise it. So it means X is approximately 8.7. All right, nice. Okay, hopefully getting the hang of this. So let's keep it going now. Let's go to our last part. Okay, so this is the angle bisector theorem. This says if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two. Okay, so that's kind of tricky. It says if a ray bisects the angle of a triangle, right? So remember that bisects means two equal parts. Okay? So if this ray makes it into two equal angles, right? Then these two are proportional. Okay? So let's take a look at this diagram over here. And we've got two different varieties on this one too. So this is the first one. This says segment BD bisects AC. So BD bisects AC, right? So if it bisects it, it makes two equal parts, right? That means this one is equal to that. So if they're asking how much X is equal to 8. All right, so if we understand what's happening here, it bisects this segment. Okay, so that's that first one. Next, let's take a look at this one. This is a little bit different. This says segment BD bisects ABC. Okay, so that's angle ABC. This right over here bisects it, right? So that means this angle is equal to this angle right over here, right? So what that tells us though is that this over this is going to be proportional to this over this, right? That's what we said over here. It's going to be proportional to the lengths of the other two sides. So let's just say that's going to be one of them, that's going to be the other. So let's check it out. So we're going to make our two fractions, and I'm just going to put that 13 on top and the 18 on bottom. Then check it over here. I'm going to put 15 on top and the X on bottom. Okay, so I'm going to show that it doesn't matter as long as we are consistent. Okay, so now we got our 13 times our X gives us 13X. We got our 18 times our 15. You might already know that in your head. That gives you 270. Right, so we're going to divide by 13. Divided by 13 cancels out. X is approximately 20.769, right? But they said 10th place, right? So we know we need one decimal, and we ask ourselves, what does that 6 tell us to do with that 7? It tells us to raise it up, right? So that means X is approximately 20.8. All right, so that's it. That's our last lesson of the year. So angle bisector theorem. If a ray bisects this, then we know that this part right over here, AC over AD is going to be proportional to CB over BD, right? This over this. So if this bisects it, this, and they're asking how much these are. Well, if that's 8, then it has to be 8, right? And then these are going to be set up in proportionals. Same thing we're going to do over here. If we have 3 lines, then we just set up our proportions. Okay, and then on our first side, we remember that the if these are midpoints, then this is going to be half of this, or this is going to be double whatever that is. All right, so make sure we do our practices and let me know if you have any questions.